As we look at section 8.8, we're talking about exponential growth and decay. The main ideas here once again come back to the idea of a geometric series where we have y equals a times b to the x. Now before, this b has always been referred to as an r, as the multiplier, but remembering that a is the initial number, the starting point, or anything like that. Now, as we talk about growth and decay, the b is representing the growth or decay percentage. If the b is greater than 1, your exponential function is going to grow. If the b is less than 1, you're going to have a decay issue, and the population or the money will get smaller each time. So, here we have our first situation. In 1988, West Chicago has a population of 13,000 people. So, that is our A. That is our starting amount. So, A equals 13,000. Now, the population has since increased at about 1.4% per year. So that 1.4%, remember percent means per 100. So our growth factor is 100% plus that 1.4%. What is that? 101.4%. Now, we need to make sure we're understanding what that multiplier is. It's not 101.4. It actually is 1.014. How did I get that? Remember, percent means divide by 100, per 100. So let's write our equation. Our equation is modeled after y equals a times b to the x. So here we go. Y, our approximate population, equals a, our initial population, which is 13,000, times b, 1.014, raised to the x. X is the number of years since 2006. Well, 2006 minus 1988, how many years is that? Well, that's 18 years. And so there's our equation. 13,000 times 1.404 raised to the 18th. Well, let's take a look at what the value of this is now as we try to compute it through. 13,000 times 1.014 raised to the 18th power. So it looks like our population approximation right now is 16,696.54. 16,696.54. I guess we should probably round, so we should say our answer is 16,696, since you can't have half a person. So that's our approximate population of that many people. Make sure you put your units of measure, and your units of measure in this case is people. Our second example, as we talks about money and interest and compounding our interest. We're going to talk about some different ways to compound over this section, compounding annually, quarterly, monthly, and other ways like that. So let's take a look at our scenario. Our initial amount is 1,000. So A equals 1,000, because that's the amount of money we're putting in the bank. Our growth factor is 7.2 compounded annually. So let's put 7.2% in for our growth factor, 100 plus 7.2%. So what is that? 107.2%. As a growth factor, though, remember once again, percent means per 100. So let's divide by 100 and get 1.072. That is our value of B. Well, the only other thing we need to find is our value of X. Well, we're talking at the balance after 5 years. So 5 years is our value of X. Here we go. Y equals A times B to the X. Always write our equation first. It's a really good rule of thumb. Y equals 1,000 times 1.072 raised to the 5th power. Here we go. 1,000 times 1.072 raised to the 5th power. Looks like after 5 years our account would have $1,415.70. I'm going to round that number to the nearest cent. So it would round to 71 cents. That's our amount in dollars. So that's our amount compounded annually after 5 years.